Hello, hello Akshara. Good evening, good evening, good evening. Good evening, Richard. Good evening, everyone. Good evening. May I know who is in the live? May I know the who is in the live? If anyone is in the live, just say me hi. If anyone is in the live, just say me hi. Hi, Yashwant. Good evening, Yashwant. Good evening. Richard, I am fine. I am fine. I am fine. Right. Good evening, Subhana. Good evening. Good evening, Charan. Good evening, Joshita. Good evening, everyone. Right. Now, now we'll start the lecture. In the last class, we have discussed up to how the ionic bond will be formed. Clear? Now, how the ionic bonds are soluble in the which one? H2O. That all we have seen. Right? My dear friends, Richard, thank you for your compliment and be focused to the lecture. This lecture is very important. Clear? Now, today we are going to see the one very interesting and very important concept that we are going to see. That is how the covalent bond is formed. How the covalent bond is formed. Now, before going to start the class, my dear friends, audio and the video is clear. Is the audio and the video is clear? My dear friends, is the video and audio is clear? Right, good. Now, okay. Right. Now, first, what are the favorable conditions to form the covalent bond? Right. To form the what are the favorable conditions to form the covalent bond? The favorable conditions to form the covalent bond. First, I electro non-metal and I electronegative non-metal and I electronegative non-metal leads to give the covalent bond. Leads to give which bond? Covalent bond. Right? Example, that is Cl and the another Cl. Now mutually it will be overlaps, leads to give the one covalent bond. Now the bond between them, it is a which bond? Covalent bond. Clear? Now this concept was explained by this concept was explained by this concept was explained by Lewis, the scientist called as a Lewis. Right? Now the covalent bond, we know, right? The covalent bond is formed due to the mutually sharing of the electron. Now how the if one A atom and one B atom, clear? Now it will be share the one electron from the B and B will share the one electron from the A and it leads to give the one covalent bond. If suppose it requires two electrons means now it will share the two electrons from the B and it will share the 2 electrons from the A, and it leads to form the double bond in this manner. Right? Now let's suppose if requires 3 electrons, if it requires 3 electrons, it will take the 3 electrons from this B, and it will take the 3 electrons from this A, and it will form the triple bond in this manner. Clear? Now before going to understand the very clearly how these covalent bonds are forming, for that one you have to know the one concept called every atom or molecule, every atom or element tries to attain noble gas electronic configuration. Which one? Noble gas electronic configuration. Now what is a noble gas electronic configuration? We know, right? Now octet complete is known as a noble gas electronic configuration. Noble gas electronic configuration means that element it should have the NS2 and NP6 should be complete. That we call it as a octet. Example, but except helium. Helium, it is having the duplet electronic configuration, that you have to remember. Right? Duplet electronic configuration. Rest all other noble gases are having the octet electronic configuration. Now, which one will show the octet electronic configuration? F to complete its octet, it requires only 1 electron because its electronic configuration is 1s2, 2s2, 2p5. It requires 1 electron to complete its octet. Now, helium or duplet electronic configuration will be shown by the hydrogen. Why? Hydrogen, its electronic configuration is 1. By taking 1 electron, it's a... Now, good evening Nitya, good evening. Now, by taking the 1 electron, now it's a duplet electronic configuration will be completed. Right? Bhautik, this is only first years, not the second years. This is a chemical bonding chapter. Now, next. Now, how the bonds are forming, how the covalent bonds are forming. Now, any covalent bond to be formed, this criteria, it is very, very important. Valency electrons. Now, the element or the atom, how many valency electrons it is having, that many bonds it will be formed. Clear? The valency electrons only. The valency electrons only will form the bonds. This point is a very, very key point you have to remember. Valency electrons only will form the bonds. Right? Now, but the exception that we are going to see in the D block elements. Now, what is the exception that we are going to see in the D block elements? When the D block elements are forming the bonds, when the D block are transition metal, if the transition metal, if it is acting as a which one? Central metal atom, then its lone pair of electrons, transition D block elements, valency electrons are considered as NS electrons and N-1d electrons. NS electrons as well as N-1d electrons. Now we'll see what are the NS electrons and what are the N-1d electrons. Now this is a nucleus. Now this is a first shell. This is a second shell. This is a third shell and this is a fourth shell. Right? Best example I will take it for your Mn. Mn atomic number is 25, right? Then its electronic configuration is 1s2. This is 2s2, 2p6. Now this is 3s2, this is 3p6 and 4s2, and after that we are having the 3d5. Right? Now you see, This last shell we call it as a what? Nth shell or valency shell. And next to the adjacent to the nth shell we call it as a n minus shell. N minus shell. Clear? This is the nth shell and this one is a n minus shell. Right? Now the d block elements valency electrons are considered as ns electrons means 4s electrons, as well as in the d how many electrons we are having, that many electrons will be considered as a which one? Valency electrons for the d block elements. Now for the Mn, now Mn is having the how many valency electrons? Now good evening Jasmine, good evening. Now Semi. Now for the d block elements is having how many valency electrons? Now Semi, my dear friends. Now the d block elements is having how many valency electrons? Now this d block is having how many valency electrons? Now this d block is having how many valency electrons? Right. Good everyone, good. Now 7, right? Now 4s2 and the 3d5. Right? Now it is having the 7 valency electrons. 7 valency electrons. That's the reason only Mn will form the 7 bonds. Mn will form 7 bonds. How the Mn will form the 7 bonds? Right. Mn in the MnO4 minus, it will form the 7 bonds in this manner. Right? Here you have to be very careful with this type of the questions when they ask. Now we'll see the next we are going to see the covalency. What is the meaning of the covalency? Means how many covalent bonds that element or the atom it is forming, or how many covalent bonds it will form, that is the covalency for it. Right? Now maximum number of covalent bonds, formed by element is known as covalency. Clear? Now the example, if the lithium, if you take lithium valency electrons are 1 and its covalency is also 1. Right? Beryllium, its covalency 2, valence electrons are 2. Next carbon, next after that lithium, beryllium, boron, its valency are 3 and its covalency is 3. My dear Richard, class will be up to the max to max, the class will be up to the 8:30 and it is having the 4 electrons. Now nitrogen, it is having the 5 valency. Now oxygen, valency electrons are how many? 6 and the fluorine valency electrons are 7 and the neon valency electrons are 8. But here we'll see what is the meaning of the covalency. Right? If H2, if you take one hydrogen, it is having the one electron. Now another hydrogen, it is having the 1 electron. This hydrogen to complete its duplet electronic configuration, it requires 1 electron. This hydrogen to complete its duplet electronic configuration, it requires 1 electron. Now it will form the one covalent bond, right? Here the bond between them, it is a covalent. Now its covalency is 1. Hydrogen covalency is 1. Now fluorine, F2. Fluorine valency electrons are 7. Now another fluorine valency electrons are 7. Right? Now this fluorine to complete its octet, it requires 1 electron. Now this fluorine to complete its octet, it requires 1 electron. Now means fluorine covalency is also 1. Now nitrogen N2. Nitrogen maximum to maximum the valency electrons are, its valency electrons are 5. Now nitrogen to complete its octet it requires 3 electron. This nitrogen to complete its octet it requires 3 electron. Means nitrogen covalency we used to think it as a 3. But nitrogen it will form the one special type of the bond, that is a coordinate covalent bond also. For that one we may think that its covalency is 3, but actually the nitrogen covalency is 4, because it will form the coordinate covalent bond, one coordinate covalent bond. Now in the upcoming in this lecture itself, now the next topic is that only, there I will explain very clearly what is the meaning of coordinate covalent bond, now how the nitrogen is forming the 4 bonds, right? Next rules to draw the Lewis dot structure are rules to write Lewis structures. Rules to draw the Lewis structures. Clear? Now what are the rules you have to remember any compound to behave as a, or to draw the Lewis dot structures? First one, central atom should be bigger in size. Central atom should be bigger in size. This is first key point. Second one, central atom should be less electronegative. It should be the less electronegative. Right? Next point, third point, hydrogen and fluorine. Hydrogen and the fluorine will never act as central atom. Will never act as central atom. Why? Any compound to behave as a central atom, what it should be there? It should have the at least, it should form the 2 bonds. But hydrogen, now hydrogen to complete its duplet electronic configuration, it requires only 1 electron. Fluorine to complete its octet electronic configuration, it requires only 1 electron. So hydrogen and the fluorine will never and ever will form the, which one? Will form the, or it will not act as a central atom, right? Next one, oxygen. Oxygen, if it is acting at the terminal position, it will form the double bond. If it is acting as a central atom, it will show the 2 covalent bonds, right? Clear? Now these are the some rules you have to remember to select the central atom of the, to draw the Lewis dot structure. These are the some rules you have to remember, so that you can easily identify which one will be act as a central atom and how to write the structures, right? Let's suppose if they have given the one CH4 they have given. If the CH4 they have given, now which one is the central atom if they ask? Now what is the first point? First point you have to remember, hydrogen will never act as central atom. Means blindly you can believe that hydrogen, if it is not acting as a central atom, means carbon is a central atom. Now carbon is a central atom. Carbon, it is having the how many? 4 valency electrons. Now each hydrogen, it is having the 1 electron. Each hydrogen, it is having the 1 electron, right? Now each hydrogen, if it is having the 1 electron, this hydrogen to complete its duplet electronic configuration, it requires 1 electron. Now it will take the 1 electron from the carbon, right? 1 electron from the carbon. Next one, this carbon to complete its octet, it requires 1 electron. It will take the 1 electron from the, which one? It will take the 1 electron from the hydrogen in this manner, right? Clear? Now in this case, this carbon, it will form the 4 covalent bonds in this manner. when this carbon, when it is forming the 4 covalent bonds, we know one bond it is having the 2 electron. One bond contain 2 electrons in this manner. One bond contain 2 electrons. So each bond contain 2 electrons, right? Then its octet is completed. Now it is having the 8 electrons and it is stable. Clear? Now, in this manner we have to draw the Lewis dot structure. But some molecules, even though it is not following the octet rule, those are stable. Why it is acting the stable? For that one we are having exceptional or exceptions for Lewis rules. Now what are the exceptions for the Lewis rules? Now what is the meaning of the exception for the Lewis rule? What we have studied now, what is a Lewis dot structure, or Lewis has said that each and every atom want to attain, or it should have the 8 electrons around the central atom, he has said. But some compounds, even though it is not having the 8 electrons in the central atom, those are stable. Clear? For that one, what we say? First one, that is a hypovalent or electron deficient compounds. That compounds we call it as hypovalent or electron deficient compounds. Hypovalent or electron deficient compounds. Right? Now, what is the meaning of the electron deficient means? Now, central atom having less than 8 electrons. Less than 8 electrons is known as a hypovalent or electron deficient. My dear friends, this word hypovalent will play very crucial role. You have to be very careful with this, the word hypovalent. Now what are that? Example, if you take the BeCl2, now you can see one beryllium, it has formed the 2 bonds. Now the beryllium is having only the 4 electrons. But even though it is having the 4 electrons in the central atom, it is stable. Clear? Now next one, BF3. If you take the BF3, now the boron, it is having the 3 bonds. Total one bond contain 2 electrons. Right? It is having the total how many electrons? 6 electrons, which is less than 8 electrons, right? Then even though it is having the less than octet, those compounds are stable. Why it is stable? That it was not explained by the which one? Lewis. Next one, some other species which is having the more than octet. Some other species it is having the more than octet. That one we call it as a hypervalent. Or electron rich species. Are electron rich compounds. Are electron rich compounds means central atom having more than 8 electrons. If the central atom having the more than 8 electrons, that one we call it as a hypervalent or electron rich compound. Example, if you take the PCl5, now phosphorus will form the 5 bonds in this manner, right? Now you can know each bond contain 2 electrons. It is having the 5 bonds. It is having the how many bonds? 5 bonds, right? Now 5 bonds means total how many electrons? 10 electrons. If you take the SF6, this SF6 is having the total how many bonds? 6 bonds. Means sulfur is having the 12 valence or 12 electrons around the central atom. Why it is having that? It was not explained by the Lewis. Clear? Next one, we are having the odd electronic species. Now what is the meaning of the odd electronic species or the odd electron? The central atom central atom is having what? Odd electrons on the odd electron on it. Now if you take nitrogen or NO2, if you take in the NO2, nitrogen, it is having the what? One covalent bond N, and here it is oxygen. Now here is the double bond O, and it is having the one electron. Now this is a one odd electron, it is present on the NO2. Now ClO2 if you take, now chlorine, it will form the one double bond O, one coordinate covalent bond, it will be formed like this, and it is having the 3 electrons. Clear? Now here you can see odd electrons on the chlorine 3, here the nitrogen one odd electron. This type of the species we call it as odd electronic species. Done? Now next, and the next type of the very important type of the bond we have seen. Sir, what is this type of the bond? You may getting the doubt. Okay, clear? Now I will clear the what is the doubt you are having for that one. Right. Now next we are going to study, that is a coordinate covalent bond, coordinate covalent bond, ORR, coordinate covalent bond or dative bond. Now what is the meaning of the coordinate covalent bond and what is the meaning of the dative bond means? Clear? Now it is a special type of a bond. It is a special type of a bond. This is a special type of a bond in which electrons are shared between two atoms. That electron was given by one atom. Clear? Sir, we did not understand. Okay, let me explain very clear. Here one A atom, it is having the some lone pair of electrons in this manner, and its octet is completed. Let us see. One B species it has came. Now this B, to complete its octet, it requires two electrons. To complete octet. Right? If this electron of this A, if it is donated to the B, then A will lost its octet. So not to lose the octet of the A and to make the B octet is also complete, what we have introduced one special type of a bond that called as a coordinate covalent bond, and these electrons of the A will be given to the B in the form of the one special type of a bond. That bond we call it as a coordinate covalent bond in this manner. Means it indicates that these electrons are between the A as well as a B. Means this A electrons, this A lone pair of electron, now it is not present on the A. It is shared between the A and B. Now we'll see with the one general example for the well-known example for it. Now oxygen contain total 6 valency electron, right? Each oxygen will contain 6 valency electron. Now this oxygen to complete its octet, it requires 2 electrons it will form. Now both the oxygen's octet has been completed. Now one another oxygen, it has came to form the bond with the O2, right? Now this oxygen number 3, this is oxygen number 2 and this is oxygen number 1. Now oxygen number 2 to complete its octet, or oxygen number 2, if it is completely, if this lone pair of electron, if it is given to the which one, oxygen number 3, oxygen number 2 will be complete it, or it will lost its octet. Now to not to lose the oxygen number 2 octet and to make the oxygen number 3 octet, what we have to do, this oxygen number 2, this lone pair of electron will be given to this oxygen number 3 in the form of the coordinate covalent bond. Means it indicates that this lone pair of electron is not present on the oxygen number 2 as well as not present on the oxygen number 3. It is sharing between both the two. It is sharing between the oxygen number 2 as well as the oxygen number 3. Is it clear? Done? Means here, if suppose this coordinate covalent bond, if it is not provided, if the covalent bond, if it is provided in this manner, if it is provided, then we have to represent the charges on the, which one? We have to represent the charges on the oxygens. Clear? You have to be very careful with this one, because charged species are unstable. Charged species are unstable and the neutral species are stable. To remove these charges on the what? Oxygens, we have introduced the one special type of the bond. That bond we call it as a coordinate covalent bond, and this arrow indicates that coordinate covalent bond. Now the electrons are going from the donor to acceptor. Donor to acceptor, the electrons are going. Clear? Now based on this concept, by using this concept, we are going to find the formal charges on the given atom. Before the Lewis has given the one structure. When the Lewis has given the one structures, that structure we call it as a formal charges. Now, Nitya, there is no any confusion among. See, this oxygen, to complete its octet, it requires 3 electrons, right? Sorry, it requires 2 electrons. But this oxygen number 2 octet has been completed. This oxygen number 3 to make it octet, and as well as this oxygen number 2 also should be in the octet. దానికోసం ఇప్పుడు ఆక్సిజన్ నెంబర్ 3 కి 2 ఎలక్ట్రాన్స్ కావాలి, దాని ఆక్టెట్ కంప్లీట్ కావాలి అంటే. ఇప్పుడు ఈ ఆక్సిజన్ నెంబర్ 2 ఈ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ ని కంప్లీట్ గా ఇచ్చేసిందంటే ఆక్సిజన్ నెంబర్ 2 కి ఆక్టెట్ పోతుంది. ఆ ఆక్టెట్ పోకుండా ఉండడం కోసం ఒక స్పెషల్ టైప్ ఆఫ్ ద బాండ్ ని ఇంట్రడ్యూస్ చేశారు. ఎందుకు ఆ స్పెషల్ టైప్ ఆఫ్ ద బాండ్ ఏంటంటే ఈ ఆక్సిజన్ నెంబర్ 2 మీద ఉన్న లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ అది 3 లో ఉంటుంది యాజ్ వెల్ as 2 లో ఉంటుంది. దానివల్ల ఈ 2 లో ఉండడం వల్ల దీని ఆక్టెట్ కంప్లీట్ అయిపోతుంది కదా, మొత్తం 8 ఎలక్ట్రాన్స్ అయిపోయినాయి. 1 2 3 4 5 6 7 8. ఇప్పుడు ఆక్సిజన్ మీద కూడా ఉండడం వల్ల ఇక్కడ చూడు 1 2 3 4 5 6 7 8 అలా ఉండడం వల్ల దాని రెండింటి యొక్క ఆక్టెట్ కంప్లీట్ అయిపోతుంది. చార్జెస్ అనేది ఏమీ ఉండవు దాని మీద. అందుకోసం అని చెప్పేసి we have introduced the one special type of the bond called coordinate covalent bond. Clear? Is it clear or still any confusion? ఇప్పుడు ఈ ఆక్సిజన్ మీద పాజిటివ్ చార్జ్, ఈ ఆక్సిజన్ మీద నెగిటివ్ చార్జ్ వచ్చాయి కదా, ఆ పాజిటివ్ చార్జ్ నెగిటివ్ చార్జ్ ఉండకుండా న్యూట్రల్ చేయడం కోసం we have introduced the one special type of a bond, coordinate covalent bond, in this manner. Right? Or still you are having any confusions? Anyone? Everything it is clear or still you are having any confusions? Right. Now, next here, next we are having that is formal charges. What is the meaning of the formal charges? Now we know imaginary charges has been given to draw the Lewis structures, right? Imaginary charges was given by the Lewis to draw the Lewis structure. Imaginary charges on atoms. Imaginary charges on the atoms was given by the Lewis. Like just now we have seen this oxygen to complete its octet. Both the oxygens octet has been completed. Now it has donated its electrons to the another oxygen to complete its octet. Now when this lone pair of electron of this oxygen number 2 has completely donated to the oxygen number 1, now oxygen number 1 will get the negative charge because it has accepted the electron. Oxygen number 2 will get the +1 charge because it has donated. Now these charges to calculate, they have given one formula called the formal charge. Now what is the formula of the formal charge? Number of valency electrons minus number of bond pairs minus 2 into number of lone pairs. 2 into number of lone pairs. Right? Now, by using this formula, we can calculate the any species formal charges. Now, I will calculate the oxygen number 3 formal charge. Or this I was explained, you know. Let's suppose if they have given in this manner. Let's suppose if they have given the carbon monoxide. I want to calculate the formal charge on the carbon. If I want to calculate the formal charge on the carbon, first what is the formula? Number of valency electrons. Number of valency electrons of the carbon is 4. And number of bond pairs. How many bond pairs this carbon has formed here? 3. Then, and how many lone pair of electrons we are having on the carbon? 1. That is 2 into 1. Now the formal charge we got it as a how much? Minus 1. Minus 1. Clear? Done? Now it is having the formal charge of the minus 1. Right? Next, formal charge of the oxygen. Now if I want to calculate the formal charge of the oxygen, now if you see oxygen valence electrons are 6 and the bond pair of electrons are 3 and how many lone pair? 2, right? 2 into 1. Total it is having the 5. 6 minus 5 it will give you the plus 1 charge, right? Now carbon formal charge it is a minus 1 and oxygen formal charge is a plus 1. Now in this manner we can calculate, right? Now this is known as the formal charge. To remove these charges only we have introduced the coordinate covalent bond so that the molecule will be stable. Right? Next. The next very important concept that we are going to see, that is known as here the next concept that we are going to see, that is valency bond theory. Valency bond theory. Why we are going to study this valency bond theory? Because now Lewis dot structure has not explained shape of the molecule. First of all, Lewis dot structures has not explained in which shape the molecule is present. So to study the shapes of the molecule and difference in the bond length, or the difference in the one molecule having the how much bond length, to calculate for that one, which was Lewis has not explained. To study that one, now the concept we have brought, that is a valency bond theory. Clear? In this valency bond theory, what we are going to study? Here we are going to study about overlapping. This is very important. Now many application parts of the chemistry will be from this overlapping concept. Overlapping and next one, hybridization. Overlapping as well as a hybridization. Right? Now, overlapping provides, by studying the overlapping, we get to know how bonds are forming. How bonds are forming. Right? Now, by hybridization, shapes of molecule we know. By hybridization, shapes of molecule. Right? Clear? Now, by overlapping concept, how the molecules are forming the what? How the molecules are forming the covalent bond. At what bond length that covalent bond is stable, that we are going to study. Right? With the example of formation of H2 molecule. Formation of H2 molecule. In the formation of the H2 molecule, first one hydrogen atom and one hydrogen atom, both are at the infinity distance. Both are at the which distance? R is equal to infinity distance. Now the potential energy formula we are having, that is K Q1 Q2 by R. Right? Now if the R is infinity, now potential energy will be equal to 0. Potential energy will be equal to 0 because there is no any force of attraction between hydrogen H1 atom and the hydrogen H2 atom, right? Now what I was doing, now I was decreasing the radius. When I was decreasing the radius, now what happens? This hydrogen atom, it is having the one electron. Now the another hydrogen atom also it is having the one electron. This is a H1 atom, this is H2 atom. This H1 atom, this H2 atom electron will attract the H1 atom nucleus. Now this H1 atom electron will attract the H2 atom nucleus, right? Clear? Now due to that one attracting, what happens? If the radius decreases, attraction increases. Attraction increases. How the attraction will happen? Due to with the positive charge and the negative charge, attraction will be happen. Now when they are attracting, now you see this hydrogen atom electron is present here. Now this some another hydrogen atom electron cloud also it has came in this manner, right? Now this hydrogen atom H2 atom electron is here. Now this region we call it as a overlapping region. This region we call it as a overlapping region. Clear? Now this what we call overlapping region. Now in this hydrogen atom electron and H2 atom electrons has shared some region. Shared some region of its electron cloud. Shared some region of its electron cloud. Some electron cloud it has shared. That when it has shared that electron cloud and that region we call it as a which one? Overlapping region. Now it how much certain bond length it has shared means from this H1 atom nucleus to H2 atom nucleus, if you find the distance H1 atom nucleus nunchi H2 atom nucleus variki, if you find the distance and that length we call it as a this H1 atom nucleus to this H2 atom nucleus, and this length we call it as a bond length. This length we call it as a which one? Bond length. Clear? Now when the two hydrogen atoms are attracting, what happened to the potential energy? Now we'll see. Now potential energy will be decreased, stability will be increased. Now what sir, how the potential energy is decreasing? Now we see attraction, right? Attraction. Now attraction means one positive charge and one negative charge should be attract, right? Potential energy will be happen due to the potential energy Q1 Q2 by R. Now one charge of the cation and one charge is anion. If these two are attracting, positive into negative value should be the potential energy value, we should get it in the negative. As I was decreasing the radius, according to this equation, potential energy should be increased. Let's suppose when I was decreasing the radius, potential energy let us increase it 100, let us do. But overall potential value should be positive into negative, that it should be in the negative, right? Overall potential energy value should be negative. Now we know, right? If the hydrogen atom when it is N is equal to 1, its electron energy is minus 13.6 we know, right? But when this hydrogen atom electron, when they have overlapped in this manner, at a certain bond length, at this certain bond length, arbitrarily I was saying it has decreased its potential energy to the minus 100. Means minus 13.6 is having the higher energy or minus 100 is having the higher energy. Minus 100 is having the lesser energy, minus 13.6 is having the higher energy, right? If any compound is attending to the stability means it will decrease its energy. Ante if the hydrogen atom, if it is present in N is equal to 1, it is having the minus 13.6 energy. But when it is forming the stable covalent bond, it is decreasing its energy. Means it is reaching to the stability. Clear? In the attraction, R decreases, potential energy decreases, stability increases. And at this certain bond length only it will form the stable covalent stable which bond? Stable covalent bond it will be formed. Right? Now next, if suppose repulsions will say, second one, repulsion. When the repulsion will be happen? When the repulsion will be happen? Now this is a nucleus. Now this is a one nucleus of the hydrogen atom and this is a nucleus of the hydrogen atom. Right? Now this is a one electron. Now this is a one electron. Right? Now still if I bring this still if I bring this close, what happens? Now you can see, still if I bring this in this overlapping region, what it will happen? Now you can see this electron will be repel, this nucleus will be repel, electron will be repel, nucleus will be repel. Means as the radius decreases, potential energy increases, stability decreases. How the potential energy increases, stability decreases means potential energy formula, potential energy is equal to K Q1 positive charge and the Q2 positive charge, because repulsion will be happened either with the positive or negative. As I was decreasing the energy, potential energy should be increased. Means as I was decreasing the energy, means potential energy has increased plus 100. Means minus 13.6 is having the higher energy or plus 100 is having the higher energy. Plus 100 is having the higher energy, right? Means any electron, if it is increasing its energy, means its stability is decreasing. Now this only based on the graph they have given. How the based on the graph they have given? This is potential energy and this is R, radius. When the two hydrogen atoms are at infinity distance, there is no any potential energy. Now you can see the straight line, right? As I was decreasing the radius, these two hydrogen atoms are attracting and they are forming the one stable covalent bond by overlapping like this. By the stable covalent bond, they are forming in this manner. Now this region we call it as a overlapping region and this length we call it as a bond length. This length we call it as a which one? Bond length. Right? Now as the bond length, at this certain bond length only they are forming the stable covalent bond. Right? Now here up to here it will form the stable covalent bond. Still if I want to decrease the radius, what it will happen? Its potential energy will be increased in this manner. Now you see this is a 0, it is having the minus 100 potential energy, it is having the plus 100 potential energy. Clear? Now in this manner the covalent bond will be formed. How the covalent bond is forming? Due to the overlapping of the one hydrogen atom at a certain bond length. At certain bond length they are overlapping, leads to give the one, which one? One covalent bond. One covalent bond it is given. I hope it is clear. It is clear. It is clear, my dear friends. Is it clear? Is it clear, everyone? Now based on this overlapping concept, now nothing is there. Here, what is the meaning? How the covalent bond is forming means, see, if this both the hydrogen atoms are at the H1 atom and this H2 atom, if both are at the infinity distance, there is no any attraction and there is no any repulsion between these two, right? Next, if these two hydrogen atoms, as the radius if I was decreasing, these two hydrogen atoms are overlapping in this manner to form a one stable covalent bond. In this manner they are overlapping. Now here from this nucleus to this nucleus, that distance if you calculate, one hydrogen atom and the another hydrogen atom, when they have overlapped like this, if you calculate the nucleus distance, these two hydrogen atoms nucleus distance if you calculate, and that distance we are saying it as a bond length. This at this certain bond length only these two hydrogen atoms are forming the bond, right? Due to that, when it is forming the one stable bond, its potential energy, hydrogen atoms potential energy will be decreased. Still if I want to decrease the radius, still if I want to make them more close, then what happens? This electron will be repel, nucleus will be repel. Due to that, its potential energy will be increases. That's it. Means only the stable bond or stable covalent bond will be formed only at the certain bond length. Only at the certain bond length only it will form the stable covalent bond. It is same. Clear? Done. Now we'll see how the orbitals are overlapping. How the orbitals are overlapping. Now by overlapping, by the overlapping concept, how the bonds are forming, now we are going to see. Clear? Before going to the overlapping concept, we have to know shapes of the orbital. We have to know the shapes of the orbitals. We have to know the shapes of the orbitals. Now, what are the shapes of the orbitals? We are having first one is a s orbital. S orbital is a spherical shape. Now, in the electron, we can find in the spherical shape only if the electron is present in the s orbital. Right? Now, here, this one, we can find the electron in this direction. 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 In the s orbital, in the all the direction we are getting the electrons, right? In the s orbital, electron we are getting in the all the direction. So s orbital is non-directional in nature. S orbital is a non-directional in nature. Right? Now, when it comes to the p subshell or p subshell, we are having three orbital. One is px, one is py, one is pz. Now, if you consider this as a z-axis, now orbital, pz orbital will be in this manner, right? If you consider this as a z and this as a y, this as a y. Now, this is a py orbital, right? Now, this one, if you consider it as a x, now the px orbital will be in this manner. Px orbital will be in this manner. Right? Now, this, you can see, p orbital, if you want to find the electron in the z, only you are getting the electron in the z. But if you want to search in the x-axis, or x-axis or the y-axis, I was not getting the electrons, right? I was not getting the electrons only. Means, p orbital is, or p subshell is a directional in nature. Is directional in nature. Right? S orbital is non-directional in nature. Means here my dear dollar, okay, thank you for your compliment. Means here, now directional orbital and the non-directional orbital we got to know. Clear? If next point you have to remember, if orbital is more closer, if orbital is more closer to nucleus, if orbital is more closer to nucleus, it forms strong bond or strong overlapping will be formed. Strong overlapping will be there. Strong overlapping. Example, like 1s orbital is nearer to the nucleus, we know. This is 1s. 1s is nearer to the nucleus. 1s orbital contain electrons. 1s orbital contain what? Electrons. Right? Now this electrons is nearer to the nucleus. Means nucleus, positive charge and the electrons are attracting. More the attraction, more stable, more strong bond will be formed. Means 1s orbital will form the strong bond. Next to 2s orbital will form the strong bond. And the 3s orbital will form the strong bond. And the 4s orbital will be strong bond. Means as the orbit number increases, strength of the bond formed will become weak. Strength of the bond formed will become weak. Now you have to say me in which overlapping now the bonds are formed strong. That you have to say me. Cl2, Br2 and the F2, I2 if they have given. Among these three, which overlapping is more effective? Among these three, which overlapping is more effective? Among the 1 to 3, which overlapping is more effective? Which overlapping is more effective? Cl2, Br2, I2. Cl2 is having the more effective, right? Right. Cl2 is having a more effective. Why? Because this is a 3p 3p overlapping. Next one, this is a 4p 4p. Next, this is a 5p 5p. Cl2, Br2 and the I2. Good everyone, good. Right? Now we'll see the types of overlapping. Now, in these types of overlapping, first one, types of overlapping. In the types of overlapping, now when the orbitals are overlapping, how they leads to give the form or how they leads to give the bond, we have to see. In these types of overlapping, first we have to know about the internuclear axis. Internuclear axis, that we call it as a INA, internuclear axis. Right? Now, along the internuclear axis, along the INA, orbitals overlaps, leads to give bonds. Right? Now, as per the NCRT, INA, they have given it as a Z. So, we are having the three axes, right? One Z axis, one Y axis, one X axis. Clear? Among these three axes, as per the NCRT, INA they have given the Z. So, we are also taking it as a Z only. Clear? Z only. Now, how many types of the overlapping and what type of the bonds it will give? Now, we'll see. Depending upon the orbitals overlapping, depending upon the orbitals overlapping. Now, here we are having the overlapping along the axis and perpendicular to the axis. Orbitals can overlap along the axis as well as perpendicular to the axis. Now we'll see. Now along the axis, orbitals, if they overlap, what the bond will give? If the perpendicular or parallel overlapping, if they give, what the bonds you will get? Now we'll see. First one, the types of overlapping. The types of overlapping, first one we are having axial overlapping. Second one, we are having the sideways overlapping. Axial or end-on overlapping. End-on overlapping or head-on overlapping. Or this one sideways overlapping or parallel overlapping. Or parallel overlapping. Right? Now, here how the orbitals overlap along the end-on overlapping or axial overlapping leads to give the sigma bond. Now, how the sideways overlapping leads to give the pi bond. Now, we'll see. First one, axial or head-on overlapping or end-on overlapping. Axial or the end-on overlapping. Here, axial overlapping leads to give, this axial overlapping leads to give sigma bond. Right? Now, how the sigma bond it is giving, now we'll see. First one in the s orbital. S orbital if you take. S orbital is a non-directional. S orbital is non-directional. In all the directions we are getting the electrons. S orbital is non-directional. It leads to give sigma bond only. Blindly believe. Sigma bond only. S orbital, one s orbital if I was taking, one s orbital and another one s orbital, one s orbital and one s orbital, one s orbital and another one s orbital. This is a 1s orbital and this is a 1s orbital. Right? 1s orbital, 1s orbital along the internuclear axis Z, along the internuclear axis Z overlaps. Then when they are overlapping, now here this 1s orbital will take the some region of the 1s orbital and it will take the some region of the 1s orbital in this manner. Now this is a 1s orbital nucleus and this is the 1s orbital nucleus. Right? Here we are having the electron and here we are having the electron. Now this region we call it as the overlapping region, right? Clear? Now in this region, in this overlapping region, now one nucleus we are having here, 1s orbital. Now another 1s orbital nucleus. Now the electron cloud has been distributed in between these two nucleus. Now this is the shape of the sigma bond. Now you can see the electrons are in between. Here the one electron and here the one electron. Electrons are nearer to the nucleus means strong attraction will be there. Electrons are nearer to the nucleus means strong attraction will be there. Here the electron cloud, if the electrons are nearer to here, now you may get a doubt, sir, how come these electrons will be nearer so that they can repel, right? So don't create that such type of the confusions because this is a 3D diagram we can't show in the 2D. Just to make you to understand, I was explaining. Okay, now this electron is nearer to the nucleus and it is having the strong attraction. Now this is a sigma bond. This is a sigma bond. Next type we are having in sp orbital overlapping. sp orbital overlapping. sp orbital overlapping. Now before going to the sp orbital overlapping, now I just want to make you clear that for the p orbitals, now with the axis I will explain so that it will be more clear for you. With the axis I will explain so that it will be more clear for you and you will not having any confusion in this concept. Wait, let me make the molecules. Now listen. Now we'll see. Wait, let me resolve. Now you can see. Now these axes are clear. My dear friends, these axes are clear. Can anyone say me, is these axes are clear? Now once you say, can anyone say me, these axes are clear? Is it clearly appearing? If it is clearly appearing, once you can you say me, anyone, better I will, instead of green I will take. Yeah, that's sufficient color. Okay. Ah, right, right. Now you can see here, right. Here, P subshell we are having three orbitals. P subshell we are having the three orbitals, right? Now, this red one we call it as a PZ orbital. White one we call it as a PY. This one we call it as a PX, right? Now, you can see for the 1p orbital, we are having the three subshells. If you consider this as a X, if you consider this as a X, this as a Z, this as a Y, PZ orbital, PX orbital and the PY orbital, both are parallel to the PZ orbital or perpendicular to the PZ orbital. Now you see me? You can see? If you consider this as a PZ orbital, if you consider this as a PZ orbital, this is PX and this is a PY. For the PZ orbital, PX and PY are parallel to each other or perpendicular to each other. If PZ orbital, PX and the PY are parallel to each other or perpendicular to each other. Parallel to each other or perpendicular to each other. Perpendicular, right? Perpendicular to each other. Now, here, if each three orbitals are perpendicular to each other, right? Yes. Now, here, let me show you. Now, this is a S orbital. S orbital is a non-directional in nature. Now, for the P orbital, INA, internuclear axis, we are taking it as a Z. INA, we are taking it as a Z. If I was taking the INA as a Z, here the internuclear axis, only the orbitals will be overlapped. Now, this is a PZ orbital. This is a PZ orbital. PZ orbital, we are having the electrons here. Now, the S orbital, we are having the electrons here. Right? Now, the S orbital and the PZ orbital, along the internuclear axis, they are overlapping. They are getting the electrons. When they are overlapping, now how they will overlap? They will overlap in this region. In this manner, they will overlap. They will overlap in this manner. When they are overlapping, they are getting the electrons cloud here. And now you can see. Right? Now, we are getting the electron cloud and this leads to give the, which one? Sigma bond. It leads to give the sigma bond. Now here you can see. Here, if you cross check, this red one is a S orbital electron. Now, here this is a S orbital electron. Now, internuclear axis, this is Z. Now, this is one the PZ orbital. Now, when they are head-on overlapping, the electron region is shared between these yellow colors are the nucleus. Shared between the nucleus, right? In this manner, they are overlapping. Add-on overlapping, when they are overlapping in this region, the electron cloud is between the nucleus. Electron clouds are between the nucleus. When the electron clouds are between the nucleus means, now here this electron, red color is the electron. Electron is strongly attracting towards the nucleus. This electron is strongly attracting towards the nucleus. This leads to give the which bond? Sigma bond, right? Done. This is the overlapping in the sp orbitals. In this manner, the orbitals will be overlapped, right? Now, next one. In the same way, if suppose this s orbital electron, if instead of internuclear axis is z, I was taking the one px orbital. Right? Now you can see what is the meaning of the px orbital. Now what the orbitals will give, whether it will give the bond or not, now we'll see. Here this is a s orbital. Now this is a s orbital pz axis. Which one? This is one s orbital. Which one? Z axis. Now this white color, it is a px orbital. Now when they are overlapping along the z axis, now pz orbital we are not having any electrons. Only we are having the electrons in the which one? Px, right? Right? When they are add-on overlapping, in this orbital we are not getting the electron. Clear? There is no any electrons here. But we are having the electrons in the which one? In the px orbital. Then how come these electrons will be overlapped? Is it possible to form the bond like this? This orbital is perpendicular to this pz orbital. It is not having a chance to form the bond like this, right? Here this type of the bond we cannot form. So that's the reason for the s orbital, and if you take the orbital which is perpendicular to the internuclear axis, there is no any bond formation. No bond formation will be happen. Clear? Right? Done. Next. Now we'll see the overlapping in the p orbital overlapping. P orbital overlap. How the p orbital and how the p orbital will be overlaps, now we'll see. Here internuclear axis I was taking the z, right? For the pz orbital, px orbital and the py orbitals are perpendicular. For the px orbital, px and the py are perpendicular. Now I was taking the one pz orbital. Internuclear axis orbitals I was taking. Right? Now pz orbital along the internuclear axis leads to give the sigma bond. Right? Internuclear axis always overlaps, leads to give the sigma bond. Now how it will form? Now we'll see. Now here right, now this is a pz orbital, right? This is a pz orbital. Now this is a one pz orbital. Now pz orbital when they are overlapping along the internuclear axis z, now in this manner when they are overlapping, now this electron cloud is nearer to the nucleus, this electron cloud is nearer to the nucleus. When these two are nearer to the nucleus, when the add-on overlapping, it is sharing its electron region in between these two nucleus, leads to give which bond? Sigma bond. It leads to give the which bond? Sigma. Right? Now same internuclear axis z, instead of taking the pz orbital, I was taking the one px orbital. Right? This is one px orbital. This is one px orbital. Right? Now you can see here. Now these RHSs are the which direction? Z direction. Now these are the Z direction. Now Z direction we are not having any electron cloud. Only we are having in the y direction, that is in the form of px. Right? Now when the orbitals are overlapping along the internuclear axis Z, we are not getting any electron. But when they are overlapping at the certain region, when it has reached, now you can see, now the sideways orbitals, in this px orbital, they are having the electron cloud. So what they will do? They will overlap at the sideways in this manner. When they are overlapping in the sideways like this leads to give the which bond? This leads to give the pi bond. When the sideways overlapping, this leads to give the pi bond. Now you can see the electron cloud is here now. The electron cloud is here. Here you can see. Here the electron cloud is here. Now electron cloud is here and the nucleus is here. Now electrons and the nucleus are far away from them. When the electrons and the nucleus are far away from them, now the bond formed between them, it is a strong or weak. There is no any strong attraction force between this electron cloud and the nucleus. Due to that, what happens? It's a strength between the electron and the nucleus decreases, means the pi bond which has formed, it is weaker than the sigma bond. Clear? Now you can see how the pi bond will be formed. Now the pi bond will be formed. Now the pi bond will be formed in this manner. Here it is a nucleus and here it is a nucleus. Right? Here it will be the electron cloud. Now here it will be the electron cloud. Here it is the electrons and here it is the electrons. Now in this manner the pi bond will be there. Right? Now the electron cloud and the nucleus are far away from them. Now the pi bond which has formed here, it is a somewhat weak. Right? Now, in this manner, the orbitals will be overlap. Let's suppose one px orbital they have given, internuclear axis Z only. One pz orbital will take, not px. One pz orbital will take and one px orbital will take. Now one pz orbital, one px orbital, internuclear axis Z overlaps leads to give which bond, Amma? Can anyone say me? One pz orbital, one px orbital, internuclear axis Z overlaps leads to give which bond? Can anyone? One pz orbital, one px orbital, overlaps leads to give which bond? Can anyone say me? This overlaps leads to give which bond? Can anyone say me pz orbital and the px orbital along the internuclear axis Z overlaps leads to give which bond? No bond. Good. There is no bond formation. Right? No bond formation, right? See, pz orbital and the px orbital. Why you are getting confusion? Now, this x is a pz orbital, right? Now this is a x is a pz orbital, y is a px orbital. Now the electron cloud is in this pz. Now here the electron cloud is in the white. Now the electron cloud is in the z. Now when these two are overlapping along the internuclear axis Z like this, in this Z there is no electrons. right? In this Z we are having the electrons, in this Px no electrons, in this X we are having the electrons. Now you see when they are overlapping, here this Z is not getting the electrons in the Z, right? Now when the Z is not getting the electrons, now here this Px when it is sideways, when it is searched, it is not getting the electron. When this Pz, when it is searched to the Pz, it is not getting the electrons. How this electron and this electron, now only two types of the overlapping we got. Only two types of the overlapping. Either head-on overlapping is possible or sideways overlapping is possible. But this type of the overlapping is not at all possible, right? Now here the electron cloud is there and here the electron cloud is there. This type of the electron cloud is not at all possible. Or this type of the overlapping is not at all possible only. So no bond formation will be happen. Right? If the pz orbital, px orbital they have taken, no bond formation will be happen. Okay? Right. Good. Now next I will write. Now here I will write the some orbital 1 and one orbital 2 and INA. Orbital 1 plus orbital 2 INA and type of bond. Now say if orbital 1 is pz, if orbital 2 is px, internuclear axis z. Now which type of the bond it will form? 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 This is first. In the second one, px internuclear axis x. Now which type of the bond it will form? Next, third, py internuclear axis x. Which type of the bond it will form? First one is no bond. Good. No bond. Second one. Second one is sigma bond. Good. Third one. Good. Second one is sigma. Third one. Good. Third one. Good, everyone. Good. Third one. Good. Now third one. Good, my dear friends. Third one. Third one, which bond? No. Third and fourth is a pi bond. Third and fourth is a pi bond, not sigma bond. Yes, third and fourth is the pi bonds. See, internuclear axis is x. Then for the x orbital, py and the pz are perpendicular. For the internuclear axis x, py and the pz are perpendicular. For the internuclear axis x, py pz are perpendicular. Means sideways overlaps leads to give pi bond, right? 3 and 4 are pi bonds. My dear friends, you have to be very careful. Now, let me write the some other. Let me write the another orbital. If suppose pz orbital they have given internuclear axis z bond. Which bond this is? Which bond this is? Good, Yashwant, good. My dear friend, good. Yashwant, good. Now next one. Next, pz orbital internuclear axis z. Which bond? Sigma bond. Good. Now px orbital and one py orbital internuclear axis is z. Good. Everyone good. Akshara, Yashwant, and Joshita. Now next, PXPY internuclear axis Z. Which bond it will give? Which bond it will give? No bond. Good. No bond. No bond. Right. Next. PX, PX, internuclear axis Y. PX, internuclear axis Y. Now you say me? PX, internuclear axis Y. Now which bond it will give? Which bond it will give? Ah, right. Good. It will give the pi bond. Right. It will give the pi bond. Okay. Now, in this manner, the sigma bond, pi bonds will be formed. Okay. Right. Good. Now, my dear friends, now I am going to stop the lecture up to here. Now, tomorrow we are going to see how the hybridization and how the O2N2 it is forming the bonds. Next, followed by hybridization. After the followed by the hybridization, we are going to see the bend rule, dipole moment, bond length. Then after that, MOT we are going to see. Clear? Right. Good, Amma. Jasmine. Good, Jasmine. Good. Now, good, Ashwan. Good. Right. Now, if you are anyone, if they are having any concerns, they can ask me. If not, remaining they can leave. If anyone, if they are having any concerns or any doubts, anyone, if they are having any doubts or any concerns, they can ask. Remaining, they can leave. Should I end the live? Should I end the live? Okay. Okay, Ma. Bye. Joshita. Bye. Bye, Akshara. Bye. Bye, Subhana. Bye. My dear friend Janakiram, when I was ending the class, you have came late. Late entry. And my dear friend, this is evening, not the morning. Okay, my dear friends, anyone still they are having any concerns? Should I end the live? 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 Anyone?